Hello everyone and welcome to the Unit 2 of the ROS Manipulation course. In this Unit 2 we are going to see how to perform motion planning using graphical interfaces. In this case I'm talking about Moveit. So we are going to perform motion planning with Moveit. And then let's refresh. What is Moveit? Moveit is basically a ROS framework that allows you to perform motion planning with a robot. Yes, so it basically allows you to plan a movement of the robot from a point A to a point B without colliding with any element of the environment or of the robot itself. Yes, so that's basically what Moveit does. Moveit allows us to perform motion planning with our robot, and it does it by providing us a very nice and easy to use GUI, user interface, yes, which helps us to interact with the robot in order to perform this motion planning. And we are going to learn how to use this. But before using Moveit, we need to create a package. Yes? So we need first to create a Moveit package in order to be able to use this user interface that Moveit provides. So that's exactly what we are going to do in this course. In this unit. And basically what we are going to do is to follow three exercises. The first one will be to create the Moveit package. The second one will be to test this Moveit package and check if everything works okay. And finally we are going to connect this Moveit package to the simulation so that everything that we do in Moveit, in the Moveit environment, it will be also executed in the simulation. Alright? Well, let's start then. So the first thing we need to do is to launch the Moveit Setup Assistant, and we will do that by executing this command here. So let's execute the Moveit Assistant, and in order to access it, we will need to open the graphical interface window again. So let's open it, and there we are. Here we have the Moveit Setup Assistant. So now, obviously, what we are going to choose is to create a new Moveit configuration package. So let's do that. And now, what we will need to do is to pass to this setup assistant the robot we are going to use, which in this case is the model URGF file from the FHDesk package. So I'm going to go to the FHDesk package, and here I'm going to copy this model URGF file to my workspace. So I'm going to copy the model URGF to home user, CatKing workspace, SRC. Now you will see that this file appears here in my workspace. There it is, yeah? So this is the file that defines my robot. So now what I will need to do is to load this file to the setup assistant. So let's find this file, which is here in the source directory, and let's load the file by clicking in this button here, yeah? So there we are. Let's wait a few seconds. Excellent. So now here, if we move this, okay, there we are. So now here, let me make this bigger, we have our UR5 robot, yes, our robotic arm loaded into the Moveit Setup Assistant. So now we can start configuring our Moveit package to this robot. Okay? Then the first thing we need to do is to set up the collision matrix, yes, and that we will do it by clicking on this regenerate default collision matrix. And what are you doing here? It will take a few seconds, yeah, but what are we basically, well, what I'm doing is to follow the instructions shown here in the exercise, so don't worry, yes, I'm not doing anything new, I'm just following the instructions here, yes? So yeah, I'm now writing this step, yeah, generating the collision matrix. So what does this collision matrix do? Basically, what it does is to define pairs of links that will never be in collision. And because they will never be in collision, they do not need to be considered when Moveit performs collision checking. Yes, so Moveit, before planning trajectories, it performs some collision checking. Yes, it checks that the robot will not collide one links with another's. Yes, so what this matrix does is to basically define pairs of links, as you can see here, that will never be in collision. And why they will never be in collision? Well, for instance, let's find two, which are quite simple. Okay, so for instance, let's say these two, or these two, for instance, yeah. So here I have the forearm link and the wrist one link, yes, and then which are this one and this one, yes. So these two links will never be in collision because they are adjacent, so they are always in collision, in fact, yes. So because of this, they do not need to be checked in the collision checking of Moveit, yes. So when Moveit performs its collision checking, it does not have to check these two links, yes, the connection between these two links, because they are adjacent links, and it is stated here, yes. So they will always be in collision, yes. You understand? All right. So yeah, we have generated the collision matrix. The next step will be to create a virtual joint. Yes, as you can see, the next step here, we will create a virtual joint, which will be called fixed base in this case. So let's click here in the add virtual joint. We are going to call it fixed base. And basically this, what does is to create an imaginary joint, let's say, because it's not real, an imaginary joint that will fix the robot to the simulation, to the world. Yes, so let's save. There we are. So we have created our fixed base virtual joint, which will connect our robot to the simulation, to the world. Then, perfect. The next thing will be to create the planning groups, which is very important. Yes, as you can see, the next step will be to create the planning groups. And this, what I'm going to do here is to basically define groups of joints for which I'm going to perform motion planning. Yeah, so I'm going to define a group of joints. Let's do it so you can see it better. So, for instance, I'm going to now create a planning group for the arm. Yes, just for the arm, without the end effector. So for the arm, I'm going to call this planning group arm. Then I'm going to select a kinematic solver in order to do all the calculations. And in this case, I'm going to select this KDL kinematics plugin. Yeah, so I'm going to select this one. Yes, now what I need to do is to define which joints will be inside of this group, which will be the joints of the arm. Yes, and the joints of the arm are basically the shoulder pine joint, the shoulder lift joint, the elbow joint, and the wrist 1 joint, wrist 2 joint, and wrist 3 joint. Yes, so there we are. Let's save this. Excellent. So what I have done here is to say to Moveit that all these joints are related to the planning group arm. So with these joints, I'm going to be performing motion planning using the KDL kinematics plugin. Okay? So now what I'm going to do is to define yet another one, which will be for the gripper. Yes, in this case, I'm going to call it hand. And in this case, since I'm not going to do kinematics calculations, I do not need to define anything here in the kinematic solver, yes? For this case, I will just define the joints, which I don't remember exactly which ones they are, but you can check it here. Here in the notebook, you have everything step by step explained with detail, yes? So basically I can have a look here. So it's the H1, if one, okay, yeah, so all of these basically. Okay, so it is this one, and this one, also this one, and this one, and finally the F3, which are this one, this one, and this one. There we are. So I think I've got it right. Yeah, I think it is. So now let's just save. And at the end I will have these two planning groups, one for the arm and another one for the hand. Okay, so let's continue. Next thing, I will define some robot poses. Okay, so I'm here in the F step. Okay, so for instance, let's define some poses, some predefined poses for the hand. One for the open hand and another one for a closed hand. Okay, so let's click here into the Add Pose button, and now I will select into the planning group the hand planning group. Yes, and now I will need to define some values for each joint. For instance, for defining an open hand, I'm going to set this joint here to minus 0.3, also this one and this one. Yes, so let's do that. For instance, this one needs to be set to minus 0.3. You will see here how the joint varies its position, yeah? It opens, as you can see here. Yeah, so let's do the same for this one, and you will see how the joint moves. There you are. Yes, and finally, let's do the same for this one here. Minus 0.3. There we are. Excellent. So now, as you can see, the hand is opened. Yes? Okay, you will see it now again with the closed hand pose. So let's name this open and save this pose. There you have it. Then let's create yet another one for a closed hand, which we are going to name close. And in this case, the values will be 0.4. Okay, 0.5 for the F1 J2 and 0.4 for F1 J3 of each one of the joints. Okay, so 0.5, 0.25 and 0.4. Okay, so basically it's 0.25, okay, let me move this here, 0.25, there we are, and 0.25 as well here. And now this one is 0.4, this one is 0.4 as well. As you can see here, let me put it a little bit closer. The joints are moving, are getting a closed position. Yes, so let's do it for this final joint, 0.4. There we are. Excellent. So let's save this pose. And now I'm going to create as well a couple of poses for the arm planning group. Yes? So let's put this a little bit smaller. Excellent. So For the arm, I'm going to define a pose which is named start, and which will look like this. Yes? So, in this case, it's... Okay, let me go joint by joint. So, the shoulder leaf joint will be -1.6, let's say, okay? It doesn't need to be exact. So, the shoulder leaf joint -1.6. There we are, -1.6. Excellent. So now, as you can see, the robot has moved, has updated its position here in the Moveit screen. So, okay, the elbow joint, it's 1.9, let's say. 1.9. There we are. And yeah, that's all. So this will be my start position for the arm. Okay. Later we'll do something with this, so you will see why I'm setting this robot pose. Okay. But these are basically predefined poses. Yes, for the robot. So which we can later say move it to plan to the start pose, for instance, and then it will plan for this joints configuration. Yes. Okay, so let's save. There we are. So we have these robot poses. Then the next step will be to set up the end effector of this robot. So here you have the configuration. So let's add end effector, because we have an end effector, so we will have to configure it here. And the name in this case will be hand. We are going to call our end effector hand. The group of the end effector is, of course, hand, which we have configured previously. And the parallel link is the link to which this end effector is connected to the robot arm. Yes, in this case is the wrist thrill link. Yes, this is the link that connects the end effector to the robotic arm. And finally, the parent group will be, of course, arm. Sorry. Excellent. So let's save this end effector configuration. Finally, we are not going to set any passive joints in this case. So yeah, we are basically done. We just need to set up some author information. You can put whatever you want here. This is mandatory. You need to put something. You can put something which is fake. It doesn't matter, but you need to put something. So for instance, I'm going to put here test and test. igniteacademy.com. There we are. Okay, and finally, what I will need to do is to create the movie package where all of these will be saved. So I'm going to go to my CatKing workspace SRC, where all ROS packages should be, and here I'm going to create a new folder which I'm going to call my robot Moveit config, for instance. Okay, so I create this folder, and inside this folder I'm going to generate my package, my movie package. So now I will click on this generate package button, and after a few seconds my package will be created. So I will have my Moveit package. There we are. So now I can exit the setup assistant, and if I come back to my Robotic Ignite Academy environment, I will see here my robot Moveit config. Yes? So now I have my Moveit config package. Okay? Excellent. So now let's test some things. Okay, yeah, here you have some explanations about the move group node, some basic information about how Moveit works. Yeah, I'm going to skip this. You can read it wherever you want, but I'm going to skip it because otherwise this video would be too long. So yeah, I'm going to jump straight to exercise 3.2, where I'm going to test this package if everything works as expected. Yeah, so for that I'm going to launch my package, which in this case is called as well my robot movie config. Yes, so I can use directly this command. In your case, maybe you have named your package with other name, so you would need to change this my robot movie config. Yes, because this is the name of the package. So for instance, if your package is named my Moveit config, here instead of my robot movie config, you would write my Moveit config. Yes, quite simple. So let's execute our demo launch file from our Moveit package. There we are. Now let's open again the graphic interface so we can visualize the Moveit screen. There we are. Yeah, this may happen to you that the window appears like this. If this is the case, you can apply this workaround, which is to execute this command in any web shell, for instance here, and the screen will be placed correctly. Yes. So here we are. Now I'm in the main Moveit screen, and I can visualize my robot here. So apparently this looks okay. This looks promising, yeah. And here I can do some tests. For instance, I'm going to do one test, which will be to plan to the start position we configured previously. I'm going to do this test to check if everything works okay. So first of all, I'm going to update my current state to make sure that everything is updated. There we are. And now I'm going to select a new goal state, which is going to be the start pose I defined previously. While creating the movie package, remember we created a pose which was start for the robot, yeah? So I'm going to plan a trajectory to go to that pose. So let's select this start pose. Let's click on the update button here. And as you can see, the robot here in the Moveit simulator, it updates its position to the start position. Yeah. So now, if I click on the plan button here, my robot should plan a trajectory to go there, and I should visualize through this screen this planned trajectory. So let's see if everything works okay. There we are. So as you can see, I can visualize this planning trajectory. Yes, as you can see, I have this ghost robot, let's say, which is performing this trajectory that Moveit has planned. And now, for instance, I can click the execute button in order to execute this trajectory in Moveit. Yes? But what happens that in Moveit I have execute this trajectory, but in my simulation, as you can see, nothing has changed. Yes? So what I'm doing in Moveit, it's not affecting the simulation. So what I'm going to do now, I'm going to change this, okay? So now I have checked that my movie package is okay, works okay. So let's stop this and let's jump straight to the next demo. Yeah, here you have some more Moveit explanations like Moveit pairing scene, Moveit kinematics handling. You should have a look at this to understand better how Moveit works. But I'm going to jump straight to exercise 3.3. And here what I'm going to do is to connect my Moveit package to the simulation so that everything that I do in Moveit gets executed in the simulation. Yes? So for that I will have to do some modifications to my package. And the first one will be to create this controller YAML file in the config folder. So let's create this new file, which will be called controllers.yaml. There we are. And inside this file, I can paste this code here. There we are, excellent. And basically what we are doing here is to defining the different controllers of the simulation. The action servers that control the joints, my robotic arm. Yeah? So for instance, I have one arm controller which has an action server, yes, which is this follow joint trajectory. So my arm in the simulation is controlled by this action server, and this arm controller has these joints, the joints that define the arm, which are the shoulder punch joint, shoulder lift joint, elbow joint, wrist 1, wrist 2, and wrist 3. Yes, and then I have another controller for the hand, which also has this action server, and the joints are the ones for the hand. Yes, so these are the joints for the hand. So basically here I'm defining this. I'm defining how the arm and the hand are controlled within the simulation. I'm telling this to Moveit. Okay. Then the next step. Yeah, here you have some, of course, for instance, I have my arm controller, which I have defined here, that controls my arm. So for instance, if I do a ROS topic list, I will see that I have this arm controller action server here. Yes, you can see it here. This is the arm controller action server. And the same for the hand. Yes, I have here my hand controller action server. Yes, which basically this is what I have written down here. Yes, so I have told Moveit how the robotic arm and the hand are controlled in the simulation, which is by these two action servers. Yes, excellent. Then yeah, let's see. Okay, yeah, so now we are going to need to create another file here in the config folder, which will be called jointnames.yalm. So let's create this file, jointnames.yalm. And inside here, I'm just going to place a list with the names of all the joints, the ones for the arm and the ones from for the hand. Yeah, I have a list with all the joint names. It's just that this file is very, very simple. Yes, controller joint names. So let's save this file as well, and let's continue. Okay, so now I'm going to fill in a launch file which has been created but is empty, which is this smart grasping sandbox Moveit controller manager. Okay, let me check here. I'm going to make this bigger. Here we have it. It's this one here, yeah? Smart grasping sandbox Moveit controller manager.launch.xml. Yes? Here you have it. Smart grasping sandbox Moveit controller manager launch XML. So if I open this launch file here, I will see that it is empty. Yeah? So what I will do is to fill up this launch file with these contents here. So let's copy the contents that are shown here, and let's pass them to this launch file. There we are, excellent. Basically what I am doing here is to load the controller's YALM file that I have created previously here. Yes, okay, this has a typo I have seen right now. As you can see, connote rulers, this is wrong, so I'm going to rename this file. It's controllers.yam. Okay, now it is okay. Okay, luckily I have seen it and I have fixed it now. Excellent. So yeah, basically what I'm doing here in this launch file is to load this controller YAM file. So basically what I am doing here is to set up a couple of parameters, and I am also setting this Moveit Simple Controller Manager plugin. Yes, which will be the one that will allow me to control the robot, the simulated robot. Yes, excellent. So now I just need to create one last launch file, which will be the one that will launch all this. So yeah, let's create a new launch file, which you can call, for instance, my robot planning execution.launch. For instance, you can name it as you want. So I'm going to call it, name it like this, my robot planning execution.launch. Create, and then I'm going to place these contents inside this launch file. There we are. And basically what I'm doing here is, as you can see, I'm loading the other configuration file I created, the joint names YAML file. I'm launching this joint state publisher node, which will tell Moveit who is the state of the joints in the real simulation. Yes, as you can see, I'm redirecting this parameter to the topic in the simulation that has this information, that has the information of the joints, which is the joint states topic. So, for instance, if we come here to the ROS topic list, we have this joint states topic. This topic is the one that contains the data of the actual states of the joints in the simulation. Yes, so I am telling this to Moveit. And I am launching another Moveit launch files in order to set up everything, to start all the Moveit environment. Yes. So yeah, this launch file basically will start everything I need. So I am now loading my configuration files. I am also connecting Moveit to the states of the joints in the simulation. So yeah, let's try this. Let's see if everything works okay. So let's launch this launch file. My robot Moveit config, yeah, and it's my robot planning execution.launch. There we are. So let's execute this launch file, and then I will need to go again to the graphical interface window. Okay, I will need to do again this in order to place correctly Moveit window. There we are. So now let's repeat what we did in the previous example, but let's see if now the robot moves as well in the simulation. Yeah, so let's change this configuration. There we are. So I'm going to plan again to the start position. So let's select here the start position, update the scene, and plan a trajectory. There we are. So the trajectory is planned successfully, as it was in the previous exercise we did. But now, let's see if clicking the execute button, this trajectory actually executes in the simulation, which is what we actually want to achieve. Yeah. So let's see. I'm going to click this execute button, and let's see. There we are. So now, the trajectory which I execute in Moveit is also executed in the simulation. Yes, so now I am actually performing motion planning with Moveit, and I can apply this into the simulation. Yes? Excellent. So yeah, we are done with this unit. Here you have some more explanation, a summary of everything you have seen, how Moveit basically works. Yes, you should have a look at this in order to understand how Moveit works. But yeah, I'm going to finish the video here. I hope you have enjoyed this unit and the video, and see you in the next video, where we are going to see how to perform motion planning programmatically using Python. Goodbye.